How to find the fundamental identities? Sometimes we don't have information, we don't have flashcards, we don't have anything to find the identities, but if you have in your mind trigonometric ratios and some keys that we're going to see today, you can find the fundamental identities. Obviously, if you have the way to put the identities on a flashcard or something, please use them because it's easier. But uh, it's good to know what is the process to find the fundamental identities, because it's going to help you in the process of working with trigonometric identities and then with trigonometric equations, okay? And to understand trigonometric functions. So we're going to start to see how to find the fundamental identities. And the first type of identities we're going to see are the Pythagorean identities. Let me show you something that maybe you will know, that it's a right triangle, okay? And the trigonometric ratios. We have sine, cosine, tangent, cosecant, secant, cotangent. And remember that sine is related with the opposite to the angle and the hypotenuse, cosine adjacent and hypotenuse, tangent with opposite and adjacent, and cosecant, secant, and cotangent is like the reciprocal of sine, cosine, and tangent respectively. So we're going to start by applying the Pythagorean identities, and as is Pythagorean identities, so we need to write the Pythagorean theorem. So what is the Pythagorean theorem? Pythagorean theorem. Pythagorean theorem. Okay, the Pythagorean theorem is for right triangles, and it says that a squared plus b squared in this case is equal to c squared, the hypotenuse. Okay, this is the Pythagorean theorem. And to find the identities, so we're going to start by dividing each term of the equation by c squared. What's gonna happen? So if I divide by c squared by c squared, okay, so if I divide by c squared, what I have here is a over c. So what is a over c? A over c is sine, but it's to the second power, so I will have sine square of the angle. Remember that in trigonometry we set the square here, but we're saying that is sine to the second power plus, okay, plus plus b over c, but b over c is cosine. Oops. Cosine, so cosine square equal, and c squared divided c squared is 1. So this is the first identity, Pythagorean identity. Okay? Now what's gonna happen if I use the same, start with the Pythagorean theorem, a squared plus b squared equals c squared, and instead of divided by c squared, I divide everything by a squared, what's gonna happen? Okay? What's gonna happen if I divide it by a squared? So a squared divided a squared is going to be 1, okay? 1 plus b squared over a squared. So b squared over a squared is cotangent squared. So cotangent of the angle to the second power equals c squared over a squared cosecant. So it's going to be cosecant squared of the angle. And this is the other Pythagorean identity. Now your job is to pause this video right now and divide the Pythagorean theorem by b squared and set the next Pythagorean identity. Okay, there are 3, so we divide by c squared, by a squared. Now it lasts to divide by b squared. Now divide by b squared and show the last Pythagorean identity. Okay, that's your job. Pause, and that's your job. Now, as we could do it with the Pythagorean identities, we're going to set the next that are the reciprocal identities. Reciprocal identities are actually pretty easy to find just by checking here. That is, sine is a over c and cosecant of the angle is c over a. So look at that, this is the reciprocal of this. Okay, so we can see that here. Okay, we have the reciprocal. So as we have the reciprocal, we just need to say that reciprocal identities. Okay, so we just need to say that sine is the reciprocal of cosecant, or cosecant is the reciprocal of sine. So I can say that cosecant of the angle is the reciprocal 1 over sine of the angle, and in the same way, so sine of the angle, okay, sorry, sine of the angle is the reciprocal of cosecant. Okay, and here we can see that the reciprocal of cosine is secant of the angle. So the other reciprocal identity will be that secant of the angle is the reciprocal of cosine, and that cosine of the angle is just the reciprocal of secant. Okay, now just by checking the last two, tangent and cotangent, you can set the other reciprocal identity. Okay, now it's your job to find the other reciprocal identity. Pause the video and get the other reciprocal identity by following the instructions that I use to find the reciprocal of cosecant of the angle and the secant of the angle. Okay, it's not so difficult. And it lasts, finally, the quotient identities. Quotient identities. So quotient identities actually are just two quotient identities, and let me show you how it works, the quotient identities. Let's start with sine, with tangent of the angle. So we're going to see new page. Okay, new page. So let's start with tangent of the angle. So tangent of the angle is equals to A over B, opposite over adjacent. So now what I'm going to do is something so simple. I'm going to divide both numerator and denominator by the hypotenuse C. Okay? And what's gonna happen if I divide A and B over the hypotenuse? A over C, as we see here, is sine of the angle. So here, this is sine of the angle. And B over C is cosine of the angle. So that means that tangent of the angle is sine of the angle over cosine of the angle. Okay, that's the quotient identity. And the other quotient identity, you can find it by using cotangent and applying the same method we did here, divided by the hypotenuse. So my hint for you is that you pause the video and now find the fundamental identity using cotangent. And these are the fundamental identities. We have fundamental identities related with quotient, reciprocal, and Pythagorean theorem. It's something really simple to use, really simple to apply, and it's something that helps you to get the identities anytime you need it. Sometimes I forget some identities. I just need to apply again the same method. And remember the trigonometric ratios. This is very simple. Thanks for watching. Just follow me. My Facebook, my Twitter, and my YouTube is the same, Hugo Fim. So just work on that, work on trigonometry. Trigonometry is really cool. I enjoy it too much because it's like using geometry and algebra and functions, and it's a big deal. Okay, so that's why I enjoy trigonometry. I hope that you enjoy it as well, because if you're going to work on engineering or math or physics or something related, this is going to be like excellent for you. And if not, you can see like the art or the perfect thing that is the algebra. And see you, goodbye, and I hope that you enjoyed the video. Bye.